Hey everyone, welcome to my session. Really glad to be here. And yeah, this is a really good city. First time I'm coming to New York. Okay. And today I would like to introduce how to build an enterprise OLAP on Hadoop, and also we'll follow up with one use case from a finance company, and I will introduce this. A little bit of myself. I'm a co-founder and CEO of Kyligence, and also creator and VP of Apache Kylin, the top-level project for the OLAP staff. And also I'm a Microsoft Regional Director and VP. Yeah, this is a community law, and I'm not a Microsoft employee. Okay, in case you will misunderstand that. Okay, so, oops. Okay, let me this one. Okay, so a little bit about our startup formed by a creator of Apache Kylin earlier over last year, and funding from Redpoint Venture and also Cisco, and also we finished another round in earlier this year. And we are offers enterprise and cloud version for the Apache Kylin. I will introduce a little more over them. And yeah, we have a dual headquarters, one in Silicon Valley and another one in Shanghai, China. We have many people over there already. And by the way, I will post over there, and you can check out to our booth. And also, we will have a live demo after this session over there, and you can come to see what product it is. Okay. So yeah, everybody is talking about the big data. Every industry, especially for the finance service industry, are transitioning to the big data, right? But the problem is, how about your traditional data warehouse? How about your existing OLAP applications? This is, I think, is a big challenge. But why it is because, you know, the data warehouse application is most of the biggest industry, you know, for the financial services, right? A lot of applications built on top of that. Without data warehouse, I don't think any finance company can survive in today. Too many people, too many data, and all the like royalty, risk management, a lot of things rely on such data technology. But it is over like maybe 20 or 30 years, okay? And a lot of our experienced analysts, they are really good at for the data itself, but not for the technology, right? But what happened in today's area for the big data? Let me talk about later, and then back to the enterprise data warehouse architecture itself. I think everyone here are familiar with this very much. We have a source data, and we will put to the enterprise data warehouse, and then we will build like OLAP, or we call it the data mart layer, and then we will expose the data through reporting or dashboard or machine learning, something else to the end user. It is optimized for the mission critical analytics. Yes, it is, right? There are a lot of, especially in the FSI industry, we always see that there is a FSI data model, right? A lot of them. And this is contains a lot of best practice from the industry with dedicated years. And also I see the ecosystem, and more important is for the experts. So people are looking for, say, like a big data expert very much for that, but actually there's a lot of trained experts in everywhere, right? So this is what happened for the traditional data warehouse. But what happened today, as I mentioned, you are asking to build something on top of big data. You are asking to provide better performance just because you have a big data platform, right? Your boss always asks this. And another thing is you have to train yourself to learn a lot of MapReduce, like Spark, machine learning, even today AI. But think about that. What's your expertise your analysts they have? What kind of tools they like, right? You cannot force them to learn something really new from that. For example, if you have just a car and then you bring a sport car to him, it's very easy for him to learn how to drive. But how about if you give him like a rocket or something else? It's not possible way, right? So what happened today is actually we call it is there's a missing part of the big data layer. So you could see a lot of front-end tools from like Tableau, Excel, Power BI, something else, connected to the different Circle engines, from Impala, from Hive, from Spark Circle, from a lot of them. The problem here is there are too many options, and you have to learn different technologies. Many of them are required to coding. Well, that is something wrong for the analyst, right? The only language our analysts love is SQL, right? They have a decade experience about that, but they have no idea about what is Java, what is about Scala, right? You will kill them. And okay, I'm telling the truth, I think. So I think our analysts, they are more like is focused on data, not focusing on technology, right? What we can do. We should not tell them, so, hey, you should learn Java, you should learn MapReduce, you should learn something. No, we should introduce something, hey, you can keep that and can leverage the big data technology. That is what Apache Kylin comes from. This project is origins in eBay about 4 years ago when we started work for eBay there. And we contributed this open source project to Apache Software Foundation in 2014. And soon it becomes a top level project. And it wins like 2 times for the InfoWorld Best Open Source Tools in the last 2 years. Hopefully this year we could, but I'm not yet. What we do is we actually bring back the OLAP to the big data layer. So we just sit on top of the data lake, and we will doing the MOLAP on Hadoop, and it's very easy for analysts can define the data model over there, and then the system will take care for all the others. It will do the pre-calculation, it will do the optimization, it will store to somewhere, we call it like a HBase or somewhere, and then it will provide a NC-SQL interface for the front end. We have ODBC Java, JDBC Java, or even like REST API. So something like your analyst just pre with like Oracle or MySQL. It's the same way. Just download the ODBC Java, like install into your like existing Tableau application, and just connect it to there. Provide a host name and a username. That's done. It's the same thing. But we can offer is a very good performance for the aggregated like query, and also this is the NC-SQL interface. So most of the analysts, they are familiar about that. They do not need to learn anything new. That's it, right? Very easy to do. And this is a native on Hadoop. You do not need to allocate like a new cluster, like 100 nodes to build something. If you already have like a Hadoop cluster, you just need to require one node beside that, and make sure your Hadoop account can talk to the Hadoop cluster. That's all. Then you can bring the service up. That's all. Then your analyst can take over everything. And it's very familiar. I can show some like a GUI later. It's just a drag and drop and define the dimension, measure, and aggregation, and a lot of other things. Just like using the existing BI tools and also say like modeling tools. Yeah, and also today we are available on-premise and also in the cloud. So this is what we are doing today. It is a middle layer, right, between the front end and also the data lake. It can speed up a lot for this way. And I can show this one. Yeah, this is based on the star schema benchmark, and compared to Apache Hive, yeah, it is not unfair because we do pre-calculation, right? So that means we are bring the data first and do some calculation and store somewhere. Yes, it is unfair, but who cares? Your analyst never cares about that. Your analyst always only cares one thing is, could you give me a report on my finger in seconds? Right. That is the right way we should do. So you can see that. And this number 2, 10, and 20 is about, we call it the scale factor. This is the term in the star schema benchmark or the TPCH, okay, or the TPCDS. 20 is about more than like 100 million data loads in your data set, and we do this comparison. Okay, and if you have interest in this is public, you can contact me. Or go to our GitHub. You can download it and to run the test by yourself. And since this is an open source project, and we have a very great performance, and this project is came to the world about like 4 years, and I will like tell you how many people are using that. Or excuse me. Good question. I can tell you later about the concurrency. Yeah, we have another testing over there, and also from the real case. It's about like more than 1,000 per second. Okay.
Did you also do the comparison between products?
We do a little bit of that, but not published yet. I can show you later. Yeah. Okay. I'll have one slide later compared to SparkSQL. Yeah. Okay. So yeah. So how many people are using that? This is just a few lists of them. More than like 500 use cases in production already. Most of them actually are big giants. Okay. Yeah, a lot of them from China, but I will say a lot of them from like UK and also like Japan, like Innovex from German and Glasspai also from German and Machine Room from Bulgaria. Yeah. You could see like internet, many of the big giants are using that. And for the FSI, okay, sorry, ABC, CBC, forget them. But I can tell you them is the top banks in China, okay, top 10. And also like CPIC, it is a top 2 insurance company. I will introduce their case later. And also like China Unipay, something like Visa and MasterCard, okay, and a lot of them. And like the Lufax, it is a biggest fintech company in China. They are using our technology very much. And also all the like telecom and also like the manufacturing, like Huawei, Lenovo, Oppo, Xiaomi, Vivo, they are like the smartphone vendors. Right. And also a lot of others. You can come to our Powered by page to check all of them. And if you have interesting, you can contact us for detailed like use cases. We have use cases in our both. You can check over there. Okay. So this is overview about what Apache Kylin is and what kind of solution we want to provide to our customer. So a little bit back to our enterprise one. I will say enterprise OLAP on Hadoop. So yeah, when we go to like the FSI industry, we always say it is enterprise. We need an enterprise feature. So a little bit background about our product. We call it is Kylin, Kyligence Analytics platform. It is based on the open source Apache Kylin. It's compatible and always with the latest release. And we bring additional value for that. See, we have a key storage, which is a column storage. So the open source Apache Kylin rely on HBase as a storage. But there are a lot of people who don't like that. Right? We using this key storage. It is purely on HDFS only. So no more HBase again. And also, but the benefit is it can speed up for the performance very much. It can up to like 40 times faster than the open source one. And it reduced half of the storage than HBase. Yeah, because there's a lot of overhead in HBase. But using this our own storage, we can optimize very aggressively for that. Yeah, and we introduced like a Kyligence robot, which is actually online optimize and tuning service. It can help you. Even you are using your open source Apache Kylin, you just need to package your logs, and it can help you to know where is the bottleneck. Is it from the disk? Is it from HBase, the region server? Is it from the network? Everywhere. We can visualize that.
How well it is integrated with Sentry and Ranger?
Yeah, we can support that. And for Sentry, that's just the beginning. But from the community, we have a lot of working on that. Yeah. Okay.
Does this sit on the cluster or does it need a separate infrastructure?
The platform? Okay, the platform is actually have two options you have. The first option is you can leverage your if your cluster is a bigger cluster, it can leverage that cluster. That means everything together. You can deploy Kylin or KIP to one of the node or even the node beside that. This is one option. But most of my customers, they are separate to that. That means they will using a bigger cluster as their computing cluster to do the pre-calculation. You run like MapReduce or like Spark. And then they will separate another cluster just for the Kylin usage. So that is a separate one. The good thing is it is a read-only cluster. So you could optimize very much for the high performance and high concurrency. Yeah, okay.
In your product comparison, you mentioned something around detailed data query not supported by HBase, supported by your local storage.
Yes, I will introduce later.
What do you mean by detailed data query?
Okay, could you just 1 second? I can introduce just after like 2 or 3 slides. We'll introduce a little bit about that. Okay. So let me go to that. Actually, we will ask you for that. So Apache Kylin is a multiple solution. So it's good for the aggregated query. But as your question, how about a detailed query? How about ad hoc query? Right. So we build this. We call it is a query push down inside our product, so that it can adapt to any of the like circle engine. So that means you can just put our things on top of there, and we will take care for all the queries. So if our cube cannot support that query, say that a detailed query, we will push down to the underlying engine, and it will back up. But the performance is guaranteed by themselves. And we call it the cube we call it the mission critical analytics, because that cube, that data model is well designed, well optimized. Right. And also we will have like intelligent cubing, and that means we will learn from your query history, and then we can optimize very much for that one. And so that you can see that pass, the right pass will be guaranteed for like sub-second latency. And for that pass, most time it will just like minutes time. I can tell you a use case. It's from VIP.com. It actually is the third e-commerce company in China. They are using like a Presto and a Kylin. And the Kylin leverage performance is less than like 1.2 seconds. And the Presto is about like 5 or 6 seconds for that one. And so that the different one, right? Okay, I can show you if you have interesting, we can go to the both and talk much. So that is, we call it as a one, and we can serve most of the queries in the industry.
Can we do transformation for sending from Hadoop to the cubes?
Sorry?
Is there a transformation possible from Hadoop to the cubes?
Yes, you can do that. Yeah, it just rely on what the metadata is always here. Yeah. Oh, you mean ETL?
Yeah.
We can do a little bit of ETL. So but we are not ETL product. So do not use that for ETL. But we have what we call it is a computing column, something like that. So you can put expression into like some measure, and then we will convert it to something, and then when we are bring the data, we will do such like calculation, and for the metrics we will bring it very well. Yeah. Yeah. Okay. So you can put like a case one or something else in there. Yeah, it's very complicated. Okay. So yeah. So when I talk about that, so we can use this stuff, we can support data exploration and discovery. This is more beyond for the OLAP stuff. But actually this is, in the big data era, our customers are always asking for that, right? So I just want to show you, this is a TBC DS. Right. This is, it's a very lovely testing, and I could tell you is we can support all the queries. Yeah, this is, we combine our technology and also the circle engine together, so that we can guarantee for all the things can work together. Okay, but what's the OLAP purpose? The OLAP purpose is always this one. We want to see speed up your mission critical analytics, right? So you have a bunch of data, but actually your boss, your analyst, your product manager, they don't care about all the data. They only just care about we call it mission critical data. So that data you should build some data model and well design it, well optimize that. So I can show something here. It is compared to the sparse circle. So you can see, this is the TPCH. Okay, most of the queries return just in seconds, and this is run on the virtual machine in cloud. So if you are using physical server and optimize very well, it will be perform better than that. And we will publish more detailed blog later about that. Okay. So yeah, and I think many of our customers, yeah, like this way. Yeah, because this is very easy to drag and drop to define the data model and to define the dimension measure. And also we have, sorry, I cannot show here. We have we call it a smarter cubing. That means you just need you can extract your circle from like a Hive or somewhere and put it to here. We can help you to optimize that data model automatically. Yeah. So this is a very easy way to use. And very important, so if the data is already be like pre-calculated, how about the result? Well, how about the user can consume that? So we actually can integrate it with the business intelligence tools very much, from commercial one to open source one. So yeah, you could use anything you want. You could ask your analyst to use your existing tools, favorite tools, say like from open source, Zeppelin, Saku, Superset, right? Or like Hue, yeah. Also, we can support most of the modern BI tools like IBM Cognos, Tableau, Power BI, MicroStrategy, and all of them. Yeah, we have ODBT Java, we have JDBT Java, and we have REST API. So it's very easy to build analytics application on top of our project and product. Yeah. Okay. So another thing for the enterprise OLAP, very important is like you mentioned, is a security, right? We support cell level SAL. That means you can grant access permission for like a cell level or even a low level. Yeah, and a lot, but just a few like a configuration is good enough. And also we support SSO, we support like LDAP integration, and we support like Kibros in the backend. And also we are working for like Sentry and others. Yeah, we actually have a customer, they are using Sentry today. Yeah, okay. So we put a lot of effort in this area to support that. Okay. So this is about the enterprise OLAP, and then let me show some use case. Okay, this is a use case from CPIC. CPIC means China Pacific Insurance Company. They are Fortune 500 insurance company, very big one, and the top 2. Okay, their customer is over like 8 million, and they have like more than 100,000 employees. Okay, it's a really, really big one. Okay, so what's their challenge? The challenge is they are using IBM Cognos and DB2 as their previous data warehouse solution, and to enable their analysts to access and analyze that like insurance policy or something else when they go to the customer. But they always do that. But the challenge they have is first we call it a long waiting time, especially in the morning. Right? Everybody go to office and open their laptop or report, right? And then it will fairly long time. And you could check the use case detail here if you want to check that. Yeah, the challenges they have is really pinpoint for the analyst, right? They told me that the story is they have to wait even like after a coffee, right? Or even like an hour. And another thing is for the concurrency. So since that problem is it cannot serve a very high concurrency, but they have, you could see, almost like 100,000 employees. So think about how about the concurrency at the morning, right? That problem. And another thing is for the high cost, right? Everybody knows that. Okay, so they have to, when they are, wanted to build some like new application, and they wanted to have such capability, and they already have a Hadoop cluster with like 100 nodes, it's a very big one, and they put it over there, and their decision is to leverage the big data technology to bring better performance, high concurrency, and lower cost. So that's why they need. Okay, what we have done is we have from the end of last year, we have contact together, and we do a lot of POC with them. This is the first big project of this customer, so they are very curious and very serious about that one. So do performance testing, concurrency testing, security testing, compatibility testing. So a lot of them, and we just go live in H1 of this year, and their analysts today very satisfied for that. I will tell you why they are satisfied that. Okay, so no change on Hadoop side. They actually are using Huawei Hadoop distribution, we call it the Fusion side, and they do not need to ask Hadoop guys to install anything on their nodes. They just need to, hey, give me like accounts, good enough, and they will bring machine beside of that cluster. Okay, so our product is a Hadoop client application. So another thing.
When you say development, you migrate the existing cubes of the older data warehouse
No.
in the new, or just put in place?
Oh yeah, actually they do. You can see, check our existing use case. Previous, there's about more than 2,000 IBM Cognos cubes. Today, they only have 2 CAP cubes. Reduced the DevOps very much. And also they bring the better performance for that. Previous, some reports will run over like hours, but today all the reports run less than 3 seconds. So that is why I thought that analysts is satisfied very much today. Yeah. So yeah, no changes on Hadoop side, and very important another thing is no additional engineering resource needed. You do not need to hire a bigger engineering team for like no Java or no like Spark or something else. What they done is done by their analyst. Their engineer just bring up the service and hand over to them. Okay, that is what happened. Okay, in the half a year. Okay, and this is the architecture. So you can see that today they still using IBM Cognos as a presentation layer. So they are supported the dynamic report or the fixed report. The fixed report it will run like daily or weekly or monthly, and for the dynamic report it will support like the drag and drop for that one. And we using a different Java to connect to our query server, and the query server will talking to the Hadoop cluster. This is for the entire deployment. Yeah. Yeah. One slide about that one. So first I want to see like the concurrency. So you could see this is our customers care about, right? Really care about that. So for the concurrency. So you can see just with like 3 nodes, we can support about like 700 concurrency per second. This is per second, and This result is from the previous testing. The latest one is already over like 1,000 per second with our latest release. And this is a very, very good, I think, because most of the OLAP system cannot serve too much the concurrency, right? And this concurrency capability is actually they are thinking about to expose something to external user because it's a high concurrency, right? And also the performance. So you could see, even with like very much like a concurrency, we can guarantee for the performance. Each carrier we can return in just seconds. Okay. So what's the benefits they get? They get, just say, replaced about 2,000 cubes. Well, this is a lot of work, right? And also reduce the query times to like 3 seconds. So they're really good. And one thing is, I remember previous, they only can put like no more than 10 dimensions in one cube, or one report on one cube. But this is because if you put too many like dimensions in one cube, it will be very slow. It will be generated like we cannot even finish it by IBM Cognos. But today they have about like 60, I remember 60 dimensions per cube. So you can put everything over there, right? And we can optimize very much. And the cost reduced significantly. Yeah, this is because they are leveraging on the Hadoop, they are leveraging the open source one, and so yeah, this is they are very satisfied for that. And this is the first project we have, and they are onboarding more projects, migrating from the legacy DW and the BI application to the big data stack with our application. Okay. So here's our customer's code. Yeah, they give us a very great comments over that. So we help them to, he said, is allow us to achieve more with less. Right? Because this technology can help them to release their productivity. So their analysts can go to their customer with a very fast client reporting and discuss for the business instant. Okay. So this is from the CPIC, and I want to just show this single slides. It's about from China Construction Bank. We call it. This is the second largest bank in the world. Yeah, it's a really big one. Okay, so previous they are using. Today they are using Teradata, Greenpoint, even like Oracle for the different like data warehouse purpose, and also like IBM Cognos, even like Saku or their own developed BI tools as their front end. And today they are already bringing Apache Kylin to this one. So they have the new, we call it the data assets in the big data layer, and also the legacy one in the existing like data warehouse. And they put the Kylin cluster on top of that, and so that is the way they call it, is the last piece of the puzzle of that. Okay, and bring the benefits for the open, so we can connect to different source and clients, and very flexible. So their end user is very satisfied for that, and another the efficiency. So one interesting thing is it speed up not only the PC, the reporting, also the mobile analytics. They have one application, and their employee can access from mobile. Well, every employee can access that.
To clarify, so they're using a combination of Greenpoint and like Hadoop cluster. And how is it? What's the reference of Teradata Greenpoint? How is that relevant?
So this is the second largest bank. So actually, every technology they are leveraging there. So they have a very big Teradata cluster. They have a very big Greenpoint cluster. They also have a very big, Hadoop cluster. Yeah, really.
And they are putting your product on top of all of this?
Yes. Yeah. So this is what they have, and we are working with them for the detailed use case later. Okay.
Does it support the dimensions hierarchy like a Snowflake schema?
Yes. We support the star schema, we support the snowflakes, and also more flexible, a more complicated one. Yeah.
And another question, right? If I've got technologies like Impala who can do the aggregation on a large data set faster, why would I need a big data OLAP? Except that. Yeah.
So yes, sometimes if you are using like MPPI, you can serve for that, and you can get the better performance. But the question is how big a concurrency you want. So if you want to high concurrency and high performance together, you have to do some trade-off, right? So what trade-off we are doing is we want to do the calculation and bring a read-only data warehouse to you, so that we can guarantee for the high concurrency, high performance. Yeah, and think about it, if you have like Impala or other things, and if you run like about 1,000 concurrency, ask your Hadoop admin. He will hit you, right? Okay, so yeah, this is my speech, a little bit about this enterprise OLAP solution. So if you have any question, I think we have still time for the Q&A. And also, welcome to our booth. We have a live demo over there, and our engineer can help you to you go through every detailed question.
Okay, how much is the learning curve involved here?
For the learning curve, actually, I think maybe just days. 1 or half days is good enough, right? Bring up it, and you will see the familiar, GUI like any other like BI tools or modeling tools, and the drag and drop for the dimension and the measures over there.
How do you refresh the...
Sorry, that's the question first.
Yeah, you showed that for the analysts, the response time is very, very fast.
Yes.
Compared to Hive.
Yeah.
How long did it take to actually do the application?
Good question. I can share. This is really depends on about your cluster resources and the data model and a high cardinality of your dimensions. I can. It's hard to give you a number, but I can give you a reference. From one use case is from China Mobile. They have their incremental data is about 200 billion data, say like 100 terabyte about that, and their cube build is just in like 1 or 2 hours over there. Yeah.
Were the chips in your example, were they on SSD or in memory or spinning disk?
On disk. So this is why our solution is can see the lower cost. So actually, you can just put your like HD, the existing Hadoop is good enough. But yes, if you are using like SSD, it will can speed up a lot.
Okay.
Yes. Sorry for your question.
So I will ask, how do you move the data from HDFS to the queue? How do you refresh it? What tools do you use?
You mean refresh that?
Yeah, move the data from Hadoop to...
We actually, this is what we call the QB engine we have. So you just need to let our engine to know your data model. And we will take care for that. We will read the data from Hive, and then we will using like Spark or MapReduce to do the calculation, and then put it into. We support incremental, and also we support streaming. So yeah, for the extreme case, if you want, you actually can put your data to Kafka, and we can read from there. And we have a live demo. It's run over like years. It's reading from like Twitter APIs. It's like do the aggregation every 5 minutes. Yeah.
So it's like a physical queue. It's like a virtual queue.
So I call it is a physical cube.
So you actually build a physical queue on HDFS.
Yes.
I thought it's a virtual queue.
Yeah. So virtual cube is say more is like the OLAP, but we more is for the like the MOLAP. Right, so that we do the calculation. Yeah, it will take a little bit like time, but it can guarantee for the performance and concurrency. Sorry, lady first. Well, this is a bigger challenge. We are not supposed to resolve that by ourselves. So many of our customers, they have like data governance, something else. Yeah, can do that. Sorry? Okay, yeah, so you mean like the cube sizes, right? So yes, if you are doing the calculation, it will, the dimension cost, right, the exposure very much. But actually, we control that very much. We read a lot of paper for that. Most of our case is just like 20 to 30% of your source data.
I'm asking if the data like a replication factor.
Or replication. So that means the data happen in the Hive and how soon it will be here, right?
Not like the HDFS replication.
Yeah. We rely on the HDFS actually. Yeah, so if you can set from your side. Yeah. Sorry, the behind first. Yeah.
So I'm trying to compare with the space cubes, like traditional. Does it have the write back? Like when we want to put some data back in the system, does it allow?
You mean write back? We do not support it today because we wanted to aggressively, to optimize for the reader only. But if you want to talk about write back, something we can do also in our product, we can like say write back to the source, right? Then we can take care of it.
Support ragged hierarchies.
Yeah, we support that. Yeah.
So do you have dimension hierarchy in the queue?
Yes. Yeah, we support that. The hierarchy, derived, joint, a lot of different optimization rules over there. Yeah.
Do you persist data or do you always read from HDFS?
What's that? Is I mean, read from that? Is it for the source or for that?
From, like, you inject, like, read from source and your memory, in-memory database comes out, or do you persist files of your cache?
We persist file. We persist file to, say, in the open source, we persist to HBase. In the commercial one, we persist to just HDFS.
Okay.
Yeah. Was that? Okay. Yeah. It's based on how many nodes you have, and this nodes is about just our query nodes, not about your Hadoop nodes. Okay, and later on we will introduce a different model. Yeah. How many nodes? Yeah. Okay, so yeah, E is our director over there for the solution architect, and maybe you can also ask for more detail and live demo, and he will do the demo in our booth later.
For business users, does Kyligence allow people to upload small reference files to control how big the
You mean the license file?
to upload like an Excel file, for example?
Yeah. Actually, you can do a little bit like customization to do that. Yeah. Actually, we have a customer. They have such like a requirement. Yeah, but we do not bring it to the standard feature yet. But they are extending now. Yeah. Yeah. Okay. Okay. Thank you very much, and welcome to our booth. And we will be there. Thank you.